Good evening, everybody. Welcome to tonight's webinar. I will just wait another minute or two for a few more people to get hooked up and get their sound on, etc. And then we'll get started with the webinar for this evening. Just while people are entering in, we do record our webinars. So you'll see usually on the top left-hand side of your screen, a little recording sound. And we just do that literally for training purposes, and we can send them on, and people who miss them get the chance to listen in. So in 1 minute, we will get started. So you've still got time just to readjust and grab a drink. I'll mention it at the end of my intro, but just for those attending, what we tend to do for these is everybody has their computer or laptop or handset on mute, but don't be afraid to unmute at any time during the presentation if you've got a pertinent question you want to ask there and then. We do have a Q&A session at the end where you get the opportunity to ask questions. And on Zoom, you do have the functionality where you can raise a hand digitally and it'll get picked up by one of the presenters. So don't be afraid to do that. But yeah, we ask for people to put their system on mute just to limit that potential interference that can kick in at any stage. That's all. That's the only reason. Feel free if anyone wants to put their camera on as well. We don't expect it. We don't ask it. I'll be turning mine off once I've done the introduction. It's just to welcome people this evening. So we are now at 33 minutes past, so I'm going to start. So welcome again to the Lely Center Midlands webinar. The latest one now in a series, and this one is on project coordination. And it's going to be delivered by my colleagues, Andy Brough and Andrew Wilson. So the two Andys who will present this evening. And the topic, obviously, it's on project coordination, but really focusing on the importance of cow flow and robot situation and where we would position them in a shed. Just to introduce my colleagues, for those who don't know Andrew Wilson, he's part of the sales team. Spent several years within sales and also with a keen interest in project design himself. He's worked on many projects and travelled countries such as Holland, Italy, Germany, looking at installations, Lely installations as well. So a lot of experience under his belt. Andy Brough he's a bit of a veteran now of the dairy industry. Way before he was working in the dairy industry, he was actually doing CAD and project coordination. And then after that joined a dairy company involved in installation, planning, looking after various different setups, and then joined Lely in 2014. So already had quite a lot of experience under his belt. And then for Lely, he's worked in a few different roles, including installation and caring for Lely astronauts. And then since last year, he's been on the actual project coordination team, heading that up. So lots of experience between the two of them. And obviously Lely's got a vast knowledge in where we feel you'll get the optimum return on where to position your robots. We will be doing, just before I pass over, we will be doing other webinars as well. I've asked in previous webinars, if you've got any burning desires to know more about various topics, do let us know, drop us a line, and we'll do our best to try and fit that in. I think we've got webinars now planned up until August with different topics. So if you also want to know what's coming up, if you drop us a line, we can fill you in on the dates. We do them every other Wednesday, so the next one will be in 2 weeks' time. Yeah, just to go back, if you keep yours on mute, thank you for doing that. Unmute if you've got a question or raise your hand. At the end, we will have a Q&A session. And before I hand over, thank you very much. Thanks for attending. Thanks for giving up your time. I know you'll get something from this. All the other webinars have been really, really good. So I'll hand over now to, I think, Andrew Wilson, who will take over the lead to start with. Hope you enjoy. Thank you very much. And we'll speak at the end.
Good evening, ladies and gents. Thank you very much, Lawrence, for that introduction. Yeah, thank you for taking the time out of this rainy, stormy night if you're in the UK. So I'll share my screen now. So there you go, and share. So yeah, thanks again for joining. I'll jump straight into it. So webinar tonight, as Lawrence has said, is about project coordination. So yeah, so for those of you that don't know who Lely Center Midlands is, so yeah, we're one of 9 Lely centres within the UK and Ireland, and yeah, we are the dairy automation specialists for the Midlands region of the UK. Currently looking after, within our patch of the UK, look after 250 plus Lely astronaut milking robots and 8 Lely vector feeding systems, and we are the largest supplier in the UK of automatic feeding systems. And tonight's webinar is about project coordination. So yeah, it's just a whistle-stop tour tonight. Hopefully we should have something for everyone. Doesn't matter what farming system you're on, hopefully we'll be able to provide some valuable information tonight. So as basically what Lawrence has already said, just an introduction to Mr. Andrew Brough, who is the project coordinator for Lely Center Midlands. So yeah, then moving forward, key bit of all Lely installations is free car traffic. It doesn't matter whether you're running a grazing system, a housed high input, high output system. The key thing behind every Lely installation is free car traffic. But why is that the case? So the free car traffic is really important because it's because the cow is free to eat and drink and rest and milk whenever they choose. Cows can live freely without restrictions or constraints. And this is really important for a number of factors, really. As you can see on the screen, factors why this is important is we do see with free car traffic systems, we do see higher milk yield per cow, less lameness, better environment for low ranking cows because there's less competition, improved fat and protein ratio, feed efficiency, more freedom, improved welfare, less labour, more milk per milking robot, and less other issues. And a lot of this is around the free cow traffic inherently reduces competition between cows. So we do see more milk because cows are able to rest more. Compared to traditional milking systems, you're not expecting them to be within a collecting yard. Typically, even the best milking systems typically have about an hour. They take at least an hour a day of the cow's time stood in a collecting yard. And really, a cow in a collecting yard isn't any benefit to the farmer or the cow in reality. There's no benefit to the cow because during that hour, she can't rest, she can't make milk, and she can't also take in dry matter intake because she's locked away from the feed fence. So for a cow, a collecting yard is dead time, and that's typically why we do see a milk yield lift per cow. Is because we're getting rid of a significant percentage of the cow's day where it's dead time for the cow. And also because of this, lower standing times, higher lying down times, we do see less lameness. Inherently, because there's less competition, we see that these lower ranking cows have a much better, they have equal opportunity, which is really a key thing with free car traffic systems with these low ranking cows. They've got the same opportunity as the higher ranking cows. If you've got first lactation heifer within a herd, she's got to be in the collecting cows with dominant cows. It's likely she's going to be at the back of the collecting yard, have the greatest standing times in the herd, because your cows that know the system are pushing through. So yeah, so just because of that, reducing that competition is a key factor why free cow traffic is so important. It's giving all cows equal opportunity to feed, rest, and be milked. We see better fat and protein ratio because typically we do get high brown matter intakes of forage because we've got more time to eat that forage. Like I say, we're not having cows stood in a collecting yard. Cow hasn't got much time in her day. She's got a lot to get in a day. She's got to feed at least 8 times a day, maybe even more. She's got to lie down a significant amount of day to actually ruminate and produce milk. And then she's got to do everything else like breed and everything else. So it's so yeah, the cow's time budget is relatively tight, and anything we can do to reduce her, take the inefficiencies out of the system is good for the cow. So yeah, just using them issues, that's why we do get the benefits received with free cow traffic. So how do we design a Lely automatic system? There's a lot of factors whenever looking at any robotic system. Like I say, we've just discussed free cow traffic, which is really important for any Lely system. But we'd like to say, when we go on farm, viewing a site for the first time, we're looking and taking notes on all these factors you see on the screen in front of you. So within Lely Center Midlands, 90% of our installations we go to look at are retrofits. We don't actually have that high percentage of greenfield sites. Typically, it's probably less now than it used to be, but it used to be the case that, oh, you need a robot, you need a new shed. That resoundingly is no longer the case, and it probably never has been the case within Lely Center Midlands. Might have been the case for other Lely Centres, but not for Midlands. The vast majority of systems we do are retrofits with either small extensions or within existing sheds. So we've got to look at the suitability of the site, look what's available to us, what can we use, how cows being, well, housing are we got cows in, what access to feed and water have they got, and how do all these factors affect car flow. So things that affect car flow, fairly obvious things, but things like passage width, crossovers, loafing areas, where feed and water is situated within the shed, any other factors such as parlours, collecting yards, things like that, all these things that affect car flow. So we get onto site and look how all these different factors influence cows, and ultimately from there we'll work out where the best place is to put a milking robot. And then there's also the other factors we take into account, so such as what is the current foot care routine or hoof trimming routine or foot bathing routine. Is that enough? You know what I mean? Is the current system doing a good enough job? And how do we incorporate the same routine or a better routine within milking robots? Because this is milking robots is such a big investment. We want to get every area of it right. And foot bathing is really important. And typically it has been, for some robotic systems, it has been difficult to design in. Whereas we've changed that now. We do put it very high up the list now. So yeah, we look at foot bathing routine. We'll also look at vet routine and separation areas for vet day and such like. This is key importance, really. These separation areas also form part of another area within Lely, which is called the 9 cow touches. So within Lely, the 9 cow touches are, so we start off, cow gets dried off, so that's cow touch 1. Cow touch 2 is a hoof trim at drying off. Cow touch 3 is she calves into the system. Cow touch 4 is fresh calved, so fresh calving checks, things like that, then the transition period. Cow touch 5 is first milking. This is based on an effort, but it will be the same in any lactation. Cow touch 6 is when we breed the cow, and if she's a perfect cow like she is with the 9 cow touches, she will get in calf on first service. Cow touch 7 is we preg check. Cow touch 8 is second hoof trim, so typically mid-lactation hoof trim. 9 cow touches vaccination, and then we're back to 1, which is dry off. That is obviously the perfect cow. So she's getting calved first save. She's got no transition issues, so she's not seen to see the vet again. The perfect cow. You should only need to touch that cow 9 times within the lactation. But those 9 times we need to interact with that cow 9 times, which is why separation areas are quite important, or at least other provision to help vet routine or help with these other interactions with cows. So yeah, we do put a lot of thought into that, and it's about ease of use for the operator and also ease of use for the cows, and making sure that handling them in a stress-free way where we're not compromising the system. Other factors we look at is slurry handling. So we look at existing scraper systems, slats, what other provisions might we need to do to future-proof the slurry handling, because it is a really important part of any system. And if we put a robot potentially where we could put in a slurry passage in the future, or a slurry channel, or a lagoon, or something like that, then we're definitely not doing the customer and the client any favours. So slurry handling is very high up the list for the key considerations we make to designs. Then following with infrastructure, so things such as office, compressor room and dairy. Very often we'll typically use existing farm offices and dairies, especially for retrofit systems. Dairy positioning is a key consideration, but definitely not a barrier to putting milking robots in. We've got plenty of experience now. We very regularly have robots 100 metres away from existing dairies, and that operates very successfully and maintains good milk quality. So, and some installations in the UK are even longer than this. I think there's one system in the UK from robot to dairy over 300 metres. So yeah, really long milk lines, but running efficiently and doing a good job. So infrastructure is not a barrier, but it is definitely key things to consider to ensure the project's delivered to a good standard. And then if we're grazing, we then look at the grazing platform, which is really important because we need to get cows to and from the robot efficiently to forage into grass. We'll touch that more later on because it is such a great grazing with the robots is it's not a challenge, but you do need the right expertise and you do need the right knowledge, and we'll touch a bit more on that later on in this presentation. Another key factor is we do look at future expansion. So we don't want to, if expansion is on the cards for future, we don't want to block ourselves in where we reduce expansion opportunities for the future. And that doesn't matter whether you're grazing system or house system. We need to constantly be mindful that when we expand the robots, typically we expand in modules of 50 or 60 cows. We're not just putting an extra 10 cows through a 10-a-side herringbone parlour. So when we're looking at future expansion, we need to think about feed space, cubicles, how will that work with the existing robot system and where we carve cows and everything else. So yeah, it's something we're always mindful of when we look at these projects for the first time. Yeah, and then finally we'll look at budget. So what is the actual budget for the project? What are we looking to achieve? Like I say, that's different for everyone, and we're trying to accommodate everyone's different needs. So as we've said, we do a lot of retrofits, and that is a lot of that is down to the budget of the project. Not entirely, but it is a key consideration. And in using all these points we've gone through today, the key aim, what we look to do is provide a system that suits the farmer's requirements and is easy to run and simple to use. Because if it's easy to run and simple to use, you're going to get the maximum benefit out of that system. Complex systems might look wonderful, but simple systems just work, and that's just through experience. And also simple systems, we do maximise the benefits automation has to offer. So we don't want to put a milking robot, take away the task of milking cows, but then replace it with excessive cleaning, or you can't do that much cleaning routine. We want to maximise the benefits that these pieces of equipment are giving the farmer, and that's really important. So we then move on. So tonight we're going to go through some basic concepts of how we design robots within Lely Center Midlands, and also what the Lely Centres do a bit as well. So yeah, there's a few go-to designs really that we know work and we know suit farmers' requirements very well. So one of our favourites within Lely Center Midlands is the head-to-head design. So yeah, nice, simple design, pretty easy to build. As you can see on this picture here, you've got a really nice loafing area. So from the end of the cubicles to the robot, really nice area in front of the robots. That one is a project we did last year. So that's a 7-metre loafing area in front of the robot. So plenty of room for cows to get in and out of robots, plenty of room to loaf, exhibit natural behaviours such as bulling. And also you can see there, we've got some slats there as well, because this shed's actually cleaned by Lely Discovery and Robotic barn scraper. So yeah, we position slats to make sure that works, and also keep that area nice and clean, reduce workload for the farmer, keep the system clean and easy to manage. As you can see there, good entry and exit because it's a nice wide shed. That shed was actually a retrofit. So I don't know if you can see next to that robot 2, just by my marker, you can actually see, and if you see that marker there above that guy's head, this shed used to have a central feed passage. So that doorway there is where tractor used to drive on the feeder wagon, feed on each side of central feed passage. To ensure that we could get 4 robots within this building and get the cubicles in, we've actually gone for perimeter feeding. So this is one span and there's another span next door. So gone for perimeter feeding, saved the need to build a whole new shed. We've not expanded the farm footprint. That was something quite important to this farmer. They didn't want a massive sprawling farm. They knew they had a good footprint. They knew they had good sheds already. They just needed to find a way to make it a bit more efficient and a bit more suitable for what they wanted to do on their farm. So yeah, so head-to-head design worked really well. Benefits of head-to-head are good for car flow. So as you can see there, we've got really nice front of robot area. So cars can get in and out of robots and can get good throughput. There's also, you can't see on this diagram, but good crossovers and good wide feed passages, good feed passages, plenty of space for cows to move. And also that's a really good thing for lower ranking cows as well to prevent competition. Also good for cow separation. So if I go back a few slides, you can see from this head-to-head design, cows can separate down this central alleyway there, where you can see my marker. So things such as vet day, AIs, any other tasks, so drying off, cows can easily be separated into a waiting area. This actually goes to the left of that, behind that robot there, to waiting area behind there, where they can have access to feed and water. And wait there comfortably, and we're not having to sort cows within the shed. So yeah, good for the cows and good for guys managing this system, and also good for foot bathing. So in some instances, people put essential foot bathing between 2 head-to-heads, so you can actually use 1 foot bath per pair of robots. Or you can use your separation areas behind the robots and put a centrally positioned foot bath there and then return back into the shed. So plenty of options for foot bathing on the head-to-head design, if it's been properly thought through from the start. One thing we'll say, the head-to-head design with foot bath is this loafing area does need to be big, because when you're putting a foot bath in there as well, you are condensing the space slightly and you can impact cat flow slightly. So you don't want too small a loafing area in front of your robots. So yeah, it's a good compact design. The clean rooms there are 4 meters by 4 meters, so 4 meters deep, 4 meters wide. It's pretty standard dimensions for a clean room for our customer base. Put good access passages behind there, so you can have 1 meter wide passages for cow separation. Operators can easily step over that 1 meter wide passage, keep nice and clean, keep in line with dairy hygiene regulations. Yeah, do a good job. And also it keeps your clean rooms nice and clean, which saves a bit of workload. And also it's really easy to retrofit into the existing building. So as we've just said there, that clean room is 4 meters deep by 4 meters wide. If you've already got a crossover on the end of a shed, so if you've already got a crossover that's 3 to 4 meters deep, and then you put a 6 meter bay on the end of that shed, you're adding 2 more meters to your loafing area, and you've got your clean room built into that bay. So it's a good design where we can just add it on the end of a shed. If the design of the internals of the shed is correct, it just means a nice, easy retrofit, which is good to keep the project within budget. So the disadvantage of head-to-head design is we do tend to have multiple clean rooms because, like I say, if we're doing separation, we've got to put these access channels down in between the robots to get cows out of the robots through the separation alleyway into the holding area. So there's multiple clean rooms. So instead of cleaning one big clean room, clean 2 small ones. That can be seen as a disadvantage for some people. The other small disadvantage, typically cows don't face a feed fence on exiting the robots with a head-to-head design. So in the perfect world, we do like to see robots exiting onto a feed fence, because usually if a cow's been in the robot, had some concentrates, facing the feed fence, they will go and stand at the feed fence, take on some forage. That gives the TN a bit of time to close. Just helps with a bit of cross-contamination. With the robots, it's pretty good anyway because we've obviously got good level of teat spray coverage. They've got to obviously walk through cars to get back to the bed. So it's not a massive issue, but it's something we do like to see, and we do try to do that whenever we can. Which, if we move on to the next slide, is just go back a few. So if we move on to the next slide, we've got the tail-to-tail design. So this is the opposite really to the head-to-head. So you've got rump of the cow there, and they're both facing that way and that way. On this shed, they've got perimeter feeding again. So they're feeding on the outsides of the shed into feed bunks. This shed in particular is it's very wide but very shallow. So the cubicle runs are only 15 cubicles long. So really shallow, wide shed, which gives us this opportunity to put quite a big collect pen in between 2 robots. And also, because this was retrofitted with an existing shed, we had to work around these steels that you can see there. There's also a steel there just in front of that robot, steel there. And there's also a steel just in front of this robot here that you can't see in the picture. So we had to work around steels as well, and also fit it within an additional 6 meter bay that you can see there. So for this design, because we had loads of width, it meant we was able to put this quite nice central collect pen, so which makes handling stock very easy. So the operator can find the collect cow, out of the cows, walk them into this loafing area here, open this gate with a key fob because this gate's an air gate, so this gate can lift up on a key fob. So one man can effectively get a cow into position just in front of the gate, open it with a fob, gate opens, cow goes in, operator shuts the gate, cow can then free to go through that robot or that robot using these little push gates. Really nice, really simple. and especially for larger herds, these automatic collect pens are very handy. And it's also quite handy to start up as well. It saves the need for erecting temporary collect pens. If we can design collect pens within the design, it does make startup a lot easier as well. So it's not essential for every design, but we do like to put them in where it's good to do so. So the advantages of tail-to-tail design are good for car separation, because as you can see there, you've got good collect pen. There's separation on both of these front of these robots, and they can return back through the collect pen to get milked again. So a lame cow can effectively live in that separation area and still have 100% access to robot, just like any other cow in the other shed. So typically they're really good for cow separation. These central collect pens are good for collecting cows and for training cows. We see that quite a bit with this design. As I've said, the face external feed barriers, if you do feed on the perimeter of the shed, these do achieve that. And also, as you can see there, we've retrofitted that onto an existing shed within an additional bay. So really friendly for retrofitting. Some of the disadvantages similar to head-to-head design, so multiple clean rooms again, which some may see as a disadvantage. And also this design isn't quite as compact as the head-to-head. So as you can see there, you've got a central collect pen. That is an especially large one. They don't have to be as big as that, but it isn't quite as compact as, say, a head-to-head design or some of the other designs we'll look at later on. So yeah, if you've got really good wide sheds, good design. If you've got really narrow sheds, not so good. So moving on, we've got the L-shaped design. So it's a 3D drawing of a project we're looking into at the moment. So the L shape here, you've got feed bunks there at the front. These sheds are actually a 2-row cubicle system. So I don't know if you can see there, you've got a single cubicle there, single cubicle there, and it's just 2 cubicles per groups of cows, because in this design, these are being run as groups of 120 cows on this large farm. So as you can see here, robots end of the shed again, and you've got the robots positioned in an L shape. The key reason we chose this design for this particular setup is because on a lot of 2-row cubicle barns with a feed fence, like this had these central feed passage feed fences, typically these can be quite narrow if they're 2-row system. 2-row system cubicles are really good because they maximise feed space. They're especially good if you've got self-locking yokes, because they give you enough feed space length to yoke all your cows for things such as TB testing and vet checks. The downside is because you're a bit narrow with your shed, it means that head-to-head isn't really an option. And that's one key reason why we look at L shape. So it's a bit narrow in its design because you've got a variable positioned basically in the same way as your feed fence, and also one across the shed. So these do suit narrower buildings compared to the head-to-head. So you've got a long, narrow shed, this is probably the design for you. So yeah, and as you can see there on these robots, both these robots got separation through a central access passage there. Around the back, there's actually a foot bath behind this clean room here. And when on foot bathing day, all the cows get separated through this once a day, through the bath, through a foot bath, through these non-return gates here. So yeah, really good design. So you can cater for separation, foot bathing, while still having good free car traffic. The advantages are good for car separation, good for foot bathing, easy to retrofit within existing buildings. As you can see in that picture, they won't fit in just one additional bay, so you may have to, instead of fitting it in a additional bay, you may need 2 or 3 bays depending on your configuration of your feed passages and cubicles and such like, but still relatively easy to retrofit. As I said, fits narrow buildings with 2-row cubicle systems. And as you can see in that one, it's sometimes possible to have multiple robots in the same clean room. So if we go back, you can see there, just in this section of the drawing, you've got 120 cows in that group there. You've got a group next to them with another 120 cows, but them 2 robots there share one clean room. So it's a bit more efficient in terms of building cost. You're just building one clean room instead of 2. So yeah, and also it's a bit easy to clean down because you can clean 2 robots at once as well. So a bit more efficient in terms of managing the labour side of maintaining robots. So yeah, disadvantage, it's a bit more complex to design, and also even though it's still relatively easy to retrofit, you do probably need to add a few more bays than some of the other designs. So probably slightly more building costs than, say, a head-to-head or a tail-to-tail or even a tandem design, which we'll look into later. Next down we've got is checkout. So we've got a few checkout systems working, and they do work really well. They typically work well for larger herds or herds that are quite heavily into the grazing. We'll go into why in a minute, but yeah, they are pretty good, and you can condense a lot of robots into very small square footage of area. So as you can see there, you've got 2 clean rooms. You've got a robot in that clean room there. You can see on that marker there. You've got a robot there, clean room here, and a robot there. So this clean room here is housing 2 robots. And these clean rooms aren't very big. So they're long and narrow. So that's a 3 metre wide clean room. It's 6 metres long. And you've got a 3 metre gap. And you've got 5 metre clean room, 6 metres long. And then you've got 1.5 metres there and a race there. So if you discount the race, you can compact a lot of robots in a very, very small footprint. And that's typically why it appeals to a lot of people in terms of retrofits, grazing systems where they're looking to reduce the capital cost of robots. It is also good for cow throughput on grazing systems because cows come into a loafing area in front of the robots. They've got go through the robots, they're out the other end. They can either get out to a new pasture of grass or another section of the shed. So it's a bit more forced. It's not as free car traffic as some of our other designs. So it is a bit more forced, but it is still free car traffic. So yeah, it's not as common as some of the other designs because it is a bit more forced, but it's got its uses when it's used correctly. So the advantages of checkout are good for cow separation because all your cows are going one way through the robot system. You can separate them all at a central point at the other side of the robot. So it's very easy to separate the cows through a separation gate. Good for foot bathing because all them cows are going in one direction. You can direct them to a central point, so you can effectively this farm will have one foot bath the other side of these 3 robots where all the cows will go through. So really handy for that purpose, foot bathing. As you can see there, we've compacted a lot of robots into a relatively narrow shed, which you couldn't do with some of the other designs. And as I've said, it's sometimes more suitable for grazing systems or low budgets where you've got to make every square foot of concrete count. And also graze systems because typically they're coming in from one paddock, going through the robots and then getting allocation to another paddock of grass. So it's just more efficient for those cows to get in, get out, get through the system as fast as possible. Downsides to checkout are car flow can sometimes be compromised because it is a little bit more forced and not a true free car traffic design like some of the other designs we've looked at. You can get a bit of car flow compromise sometimes, which is why we feel if you do go for checkout design, you've got to have pretty good loafing areas in front of the robots and behind the robots. And that's to reduce the competition of the robots. That's to stop lower ranking calves, heifers, getting bully calves going past them in these loafing areas and basically standing in those loafing areas for a long period of time before they actually go through the robots. It's just to help car flow and reduce competition. So yeah, go check out. You've got to you've got to think about cow flow pretty hard and have a good solution for that. Yeah, and also we check out it's quite hard to achieve return separation. So if you've got a sick pen cows or freshly calved cows, where you want them to maintain a little isolation pen on the road, but always have access to the robots as well, it's not impossible on checkout, but it's very difficult to achieve. The other designs, it's a really, really easy thing to achieve. And that's why their designs are more popular within the Midlands area, just because we can look after these special need cows a little bit better with these other designs. Checkout also doesn't fit many retrofit designs in our area, just because you may have to put on a significant amount of shed work on your sheds to make it work, to make your loafing areas big enough. Yeah, it just doesn't lend itself to many sheds. That's not to say it's not right for the sheds where it is in, but it doesn't lend itself to many. You can see this shed we've had to do this as a bit of an offshoot. If we go back, that shed there is where the feed passes and the cubicles are. So the cows are actually coming out of that shed into this shed through the robots and then back in again. Because this guy couldn't put bays on the end, and he didn't want to undo some of his cubicle work and feed passage work he'd already put in, because obviously he'd already invested in those. So this was a compromise. It's working well, cows are working well in the system, but it just shows that it is a bit more of a compromise than some of the other designs we've done. Also, a checkout, it's very difficult to split groups. So as you've seen in that previous slide with the L-shaped design, very, very easy to split groups. So it's very easy you can either run 4 robots in one group on that previous design, or put a gate in and have 2 groups of 120 cows. Checkout, as you can see in that design, you can't have them 120 cows and 60 cows on 3 robots. You're basically stuck with running 150, 180 cows through that group. So you've not quite got the flexibility of some of the other designs. Then we've got the tandem design. So yeah, this is a good design. It's also probably one of the cheapest designs to actually build on a retrofit. So this is slightly, yes, this is a different orientation, but basically cow can enter the robot that way. She can go turn, so basically goes in the robot, comes out of the robot, can go that way. Or she can then, if she's separated, she can go into a holding pen there through an automatic gate. When this cow's finished milking and gets exited out, this cow will then go through this robot into this separation pen at the end. So this design is it's a good design for separating cows. It's a cheap design to build because, as you can see, 1 clean room can accommodate 2 robots. A lot of positives in the right shed. So yeah, positives are good for cow separation. As you can see, you can combine more robots in 1 clean room, which makes cleaning a bit easier. Can easily be retrofitted with existing buildings, because you can either put these across the gable end of a shed, or as you can see there, that's in line with the cubicles on the end, which is a bit more of an American design, but it does work. And then the disadvantages, as you can see, return separation is more difficult in its design, because you can't get these cows once in the separation area. You can't effectively have a cow living there and circulating to the robots again. Pretty much once in the separation area, it's human interaction that's got to get her either back into her group or back into the robots. So yeah, not as ideal for return separation as the other ones. And also, because you're asking a cow there to wait in that area, you can slightly compromise robot capacity, because you are that robot, while you're waiting for that cow to go through to the other robot, it's reducing the capacity of that robot. It can't milk another cow until that cow's moved out of the way. So you do reduce your robot capacity slightly in that design. So yeah, good design, but not quite as popular as tail to tail or head to head, or even L shape. So now I've looked through all them. They're typically designs we use in our housed herds or grazing herds. what other key differences do we have to think about when we're grazing cows with robots? Grazing is going to become more popular, and we're seeing it within the centre now. Milk buyers, public opinion, we're definitely going to have to graze cows more. And we need to get rid of the myth that cows can't graze on robots, because our colleagues in Southern Ireland have definitely proven that robots and grazing do work. So as you can see there, we've got a typical farm there, small robot unit in the middle, and split the farm into 3 blocks, A, B and C. And that's what drives cows to the system. So block A and B, you allocate 40% in each block of the grass of the cow's daily dry matter intake from grass. And then block C, you've got 20% allocation. So block C is a bit of a management block. That's a night block, so pretty close to the robots. You don't allocate too much feed because they'll have taken the bulk on in the day. But if you do need to work with your cows or handle your cows during that night period, or to get more milkings, that's where your C block comes in very, very handy. This is the perfect situated farm. This was actually a greenfield site. So they could plonk the robot unit right in the middle of the grazing block. You don't have to do it this way. You can have your farm buildings on one edge of your farm, but you do need good trackways, which goes on to, we need to look at the location of the grazing platform. We need to look at where water is situated on the platform, car tracks to get cows to and from the robots, and paddock sizes. So robot design is important, but we need to bear in mind all these factors, where the cows going from block A to block B to block C, and make sure that we design the robot so we're not compromising that. Like I say, it can be a challenge sometimes, but we need to make sure that we're making sure the system's fit for purpose. And then we look on to Lely designs for large cow numbers. Robots are not just for the up to 200 cow dairy farm anymore. There's more and more large Dairy Excel customers going in all the time, especially within the States. Within Lely, we've got a concept called Dairy Excel. It's called the Red Cow Community. So that's anyone milking over 500 cows on Lely robots. And across the world, there's currently 118 farmers milking with over 500 cows each on Lely robots. They're working across over 20 countries of the world, and they're all milking, between them 118 producers, 100,000 cows robotically on large herds. So they have pretty fundamentally proven that robots and large herds do work. So just look here, you'll see something you've seen again earlier. This is a design we looked at for a client. So 3-row cubicle system rather than a 2-row. You've got 8 robots within this shed. This was a greenfield site. Groups of 120 cows, central feed passage, and you've basically got 4 pairs of head-to-head robots with 2 central separation areas and collect pens as well. So nice, compact, pretty compact system. Like I say, it's and the separation areas help with cow handling, vet days and such like. So quite efficient. Really good system. It's quite a common design for us that to be found on the Dairy Excel front. And as you can see, they're very modular. So the beauty of robots is they are a modular design. So you can basically see all these head-to-heads are exact copies of each other. So which for when you're expanding large cow numbers such as these, if you're going up 120 cows, you basically build a quarter of that shed, a module of that shed, and go again and go again. So it's very easy to, even though you can't put an extra 10 cows aside like you can in a parlour or an extra deck on a rotary, if you're expanding sustainably, where you've got to expand cubicle capacity, feed fence capacity, it's also very easy to expand robot capacity as well, whilst not increasing labour requirement as well. So that's the beauty of robots and large herd designs. They are very, very modular designs. And as you can see, they're very simple. It's pretty much the same design, just replicated on a larger scale. So nice and simple, and pretty easy to adopt, really. So yeah, and as you can see there, even on large herds, we do keep to quite small cow numbers per group. So like I said, there are effectively 4 groups of 120 cows. So they'll be milking 480 cows on that system potentially. We do go up to typical maximum day XL projects of up to 240 cows per group. And that really is the maximum, because it's any more than that, it's hard to manage, collect cows. Yeah, you can create bottlenecks, and you do get issues. What we want is simple systems that are simple to manage, and that's what we get with these modular systems. So we don't tend to have groups greater than 240 cows, even on dairy XL designs, in one group. Just makes management far, far easier. Yeah, and simplicity is the key. Just looking at another design here. So that was a design for 8. This is a design for 12. So this is from a design that's been built in the States. So a little bit different to how we would do it, but built for 12 robots. This was actually a farm that was going to go to Lockhart on our Red Car Revolution tour of the States. That was going to go ahead until it got stopped by Corona, but hopefully we'll be able to go in it next year. So if anyone's interested in that tour of large herds in America, please register your interest at the end. I'm sure we'd be glad to take it, I'm sure. So yeah, so just look at this design, a bit different to what we'd typically do, but you've effectively got 4 sections of the shed. You've got one side there with feed passage length of the shed. You've got a central feed passage, 2 groups each side of that, 1 group each side of that, and then another group on the other far perimeter side. So you're pretty much looking at this design. You've got groups of either 150, 180 cows. So potentially, if it's 180 cows, you could potentially be milking 720 cows on this design. This design has been built, so I look forward to seeing this myself next year. But as you can see there, some similarities. Feed fence is really important. Separation areas on the end. So if you look on at my marker there, if I draw a line up the shed there, separation areas at the end of the robot. So this is a tandem design, so car goes through there to be separated. So tandem design, so all your separation cars are all in one area, which is good for the vet day. Efficient use of labour as well, so staff can get around the system very easily. Your vets have got one massive clean room there and one massive clean room there, so very efficient in terms of labour management and maintenance. And then you've got your dairy here, which is pretty efficient, and this system actually loads direct onto milk tankers, so which is a bit more common in the States than the UK. So yeah, really good design. Bit different to what we do in the UK, but still a good design. And if any guys are interested in potentially milking robots or large herds, then the visit to the States will be very beneficial. So yeah, and yeah, I'd like to conclude that there, if that's all right. Hopefully that's been insightful, and feel free to give some questions.
Thank you very much for that, Andy. Very insightful. So we're at the end of Andy's presentation on the benefits of free car traffic and what kind of things we consider when we're looking at a layout. As it's been pointed out, it's not often we actually do have a greenfield site in front of us. So most of the time we are looking at retrofit. And Andy's kind of gone through some of the things, the areas that we look for and we look at and we have to take into consideration before making a proposal. So yeah, really good and great seeing some of those pictures of existing setups and some ideas and designs of what can be done. I just want to open up now. Any questions out there? Burning questions. Use the digital version if you like, so you can unmute and ask traditionally. You can put your hand up, or there is the group chat, which Lizzie has kindly given us an example of how you can ask a question. So we will start with that. I don't know if Andy Bruff wants to answer this, or you, Andy Wilson, but she's asking the question: how important is separation if you are on a tight budget?
So yeah, I'll take that one. Yeah, it's beauty of separation. If you are on a tight budget, depending on the layout of the existing shed, we can put separation at a later date. So such as if you look there, if you had a head-to-head design on the end of the gable end of a shed, like I say, you could put one bay on to house the two robots with a view to add another bay on at a later date to put separation behind. So you've got an actual area behind the robots to have a separation area in the future. So so long as it's factored in when the robots are initially constructed and there is a plan for separation one day potentially, then we can quite easily factor that in. So yeah, it needs a bit of hind foresight, but it can be done very effectively.
Okay, thank you. Any other questions we've got? You can also ask questions via WhatsApp if that's easier. We're allowing the Andes to get away far too lightly here. We must have some burning questions. Let's put them on the spot.
It's Lizzie here, so I'm just going to ask another question and probably direct it to both Andys. What are the common things you may see on a farm if there's a customer, they're asking for a particular design, and common issues, common problems that you may come up against?
I'll let you take out first, Andy Bruff, and then I'll chip in.
Yeah, no problem. So the common issues, well, I'm not very good at answering these. The common issues that we come against, basically getting things to basically fall into place so everything will work correctly. You can get the feed cows to the feed fence efficiently. You can get your milk to the tank, and you can get all your airlines into place. You can get everything organised. Yeah. So yeah, if I've answered the question.
Yeah, and common thing we see, and it's not a fault of anyone, but it is a common thing we see, especially on retrofits, is farmers. Like I say, I'm a farmer's son, so we hate undoing what we've already done. So if we've invested in a building, put a new building up, put cubicles in, and then someone comes from Lely and says, "Oh, you get a bit better calf if you took 2 cubicles out there," that can be a bit of a challenge. But I promise you, if when we do it, we do get a benefit. So it is an investment. So yeah, it's sometimes achieving car flow means that we've got to maybe lose a couple of cubicles or make slight alterations to the shed. So yeah, as long as we communicate that well, it's definitely beneficial if we sometimes do, especially if we're doing it to make that area in front of the robots a little bit bigger, because that loafing area in front of the robots is so important. We do have guys with smaller areas that do function well, but the guys that have the bigger areas, especially if they foot bathing in those areas as well, they do see big benefits by taking a row of cubicles out and giving the cows a bit more space. you definitely get it back. You definitely get it back in terms of better cow flow, more milk per cow, less competition among your cows. Making sure cows have got space is really, really important. So that's probably one challenge we see slightly with retrofit designs, is just ensuring we give the cows enough space to perform and do a good job.
Yeah, just to add on that, Andy, I'm not sure who's seen this data, but one of the things that we probably find we have to explain more is the free cow traffic, because it is something Lely invented. I know when I joined Lely, I needed to get my head around the concept. I found it quite new that cows were given the option, whether it was we milked in a tie stall barn, but I remember the first parlours going in, and then I spent a lot of time around rotaries. It guided or forced was so much more the norm for me. But the proof is in the pudding. So one of the things I just wanted to mention is when Lely, well, in the Netherlands, that they've obviously got a national body like AHDB Dairy, and every year they collate lots of data. It's an independent organisation, and yet again last year, this is based on 1.3 million cows, so it's a big research field. Yet again, Lely astronauts produced more milk than any other form of equipment. So it was nearly 10% up on traditional milking equipment, whether that's a parlour or rotary, and nearly 4% up on any other robot. So when we are challenged by maybe our competitors or anybody out there to say, this free cow traffic, I just can't get my head around it, the proof is in the pudding that you've got to trust us. And so if we are saying take some bays away and make a bit more room, or if we're just trying to get across what free cow traffic is about, be assured that there's over 30 years of research and evidence to back up why and how free cow traffic does work. So I just wanted to add a little bit onto that. We do have another question come in. So for people feeding their own corn, where would you suggest storing it?
So yeah, I'll take that one. So yeah, people do more and more. We're seeing people feeding their own produced corn, whether that be roll wheat, barley, or even buying straights, so such as bulk straights, such as soya hulls or wheat feed. Not that I recommend feeding those feeds, but on low cost systems where you need to keep feed costs down, it is becoming more popular. It's also becoming a bit popular in the States, where they're feeding a lot of maize distillers, stuff like that, just to keep feed costs down, really. So yeah, it is becoming more popular. As long as it's good corn of good quality, a lot of people are putting it in bins or lofts, or there's even bins now where you can self-load it. So yeah, it's still being stored in bins primarily. The important thing is, if you do feed your own corn, we do have a commodity feed on the Lely, on any Lely robot that can retrofit. So it's a special auger within the feed that reduces the risk of these feeds bridging, because like I say, that's the risk with a lot of these home produced feeds or these straights, that you can get a bridging risk or even blends. So we do have commodity feeders, which is a slightly different auger within the robots. We've also got feed presence sensors on the robots. So if you do get a blockage, your robot will basically tell you there's no feed getting in the hopper, you've got a blockage in your auger somewhere. And for these feeds, that's pretty important, because you can be thinking you're feeding your cows on a robot, everything's wonderful, because you're not in the pit waiting for the corn to rattle into the feed trough. You think your cows are being fed, when in actual fact there's a bridge in the auger, the motor's turning, no feed's dropping, and you see milk production and visits per cow drop. So yeah, it's loads of people are feeding their own corn, but there's just some key points to consider.
I have a question. Based on some of the concepts we've seen today, how long does it take for you to make one of those drawings that shows, you know, the dream in real life?
I'll let Mr. Bruff answer that question.
Take me anything up to half a day to produce, depending on the complexity of it. The one, as you saw, that was a mirror image was relatively quick, but the more complex they are, especially into existing buildings, the retrofits, they can take quite a long time. Any more?
Okay, thank you. We've got another question here. What is the most profitable and efficient number of cows per robot on a house system?
So yeah, it's a good question, that is, because there's no real right or wrong answer. I suppose it ultimately comes down to what do you want to do on your farm, because there's two ways of looking at it. Typically through a Lely robot, we'd say average to good performance. We have got some guys that are pushing significantly higher milk yields per robot than this, but as an average, we look for all our producers to do 2,000 litres per milking robot per day. And that, you know, if that's pretty good managed and a pretty profitable farmer. So that's a bit of a benchmark for us. We've got some guys doing 2,500 litres a box. But as an average, 2,000 litres a box is a pretty easy to manage but profitable system to run. So based on 2,000 litres per milking robot per day, there's a few ways to achieve that really. You can achieve that with 50 cows doing 40 litres each a day to get to 2,000 litres a box, or you can do it or you can do it 60 cows averaging 33.33 litres. And I suppose what it comes down to is what the most profitable and efficient system depends per farm. So if you're a farm that can grow amazing quality forages, you can grow maize, you're on pretty decent quality land, you can grow good forages, and you're on the correct milk contract, so you're on a supermarket contract, it's typically a liquid volume contract, you're looking to push your cows pretty much as hard as you can, and while maintaining good fertility performance and everything else and good animal health. So it probably pays you to push 50 cows doing 40 litres a day. The other side to that is you're a bit more of a marginal area. You can't grow maize to the same standard or make the same quality of forage. You're on a components-based contract, so you're with Arla on a manufacturing contract. You're probably better looking to do 33.3 litres a cow with a lower concentrate input. Still making good quality forage, but you just keeping your feed costs that bit lower per cow, not necessarily per litre, but per cow, you're just a bit more in control of those feed costs. So yeah, there's no right or wrong answer. Ultimately, you've got to have, personally, this is a personal thing I believe in. I think you've got to have a good understanding what you want to do as a business. So you've got to understand, like I say, whether you're liquid, what is going to pay you the most, whether it's liquid contract or solids. You've got to have a plan from the get-go. Right, we're going to have just over 50 cows doing 40 litres a cow robot a day. You know, set yourself up, set your stall out, make sure you've got the forage quality that you need to achieve them results. Yeah, so it's all about planning and planning where you want to be. But yeah, both systems can be equally profitable. can just see another question below
Yeah.
that, so I'll follow through.
Yeah. Do you need to alter TMR rations cow nutrition when milking through robots instead of a parlour?
It depends what you're doing for your parlour. So if you're feeding concentrates through your parlour, you might not have to alter your diets as much as you think. Our FMS, we've got a dedicated in-house FMS team, Samantha Hargreaves and Izzy Lester, and that's very much their area of expertise. So yeah, it's you may have to make slight alterations. If you are total TMR with no feed in the parlour, then yeah, you will have to make quite a significant change. But the beauty, if it's managed properly, you might have to change the diet, but you might reduce your feed cost per cow. It's a bit of a misconception that go to robots, got to put more concentrates to the robots, and we're going to have higher feed costs per litre. However, the beauty of robots is we can really, really target these feeds to the robot, and also we've got the feed programs to target better, such as DLM, to really target these high performing cows, and also to look at these cows that aren't performing quite as well, whether they're going through a staler stage lactation or they're just not genetically capable of some of the guys, some of their herd mates, that we can really target our feed and make sure that every kilo we're putting down the spout is giving the most benefit to you guys out on farm.
Okay, fantastic. I think we've gone all the questions we've answered now in the chat. Has anyone got any final questions before we wrap it up? Any burning questions? Of course, you can come to us individually. There's Andy's number on there, yeah, ask any questions you like by email or phone. So if there is no more, which is how it is looking, thank you to both Andys. Thank you very much for doing a great job of sharing your knowledge and experience with us. And thank you for everyone for attending. We do appreciate it. So thank you for making the effort. And yeah, I'll bid everyone a good evening. Stay safe, and we will hopefully speak to you all again in 2 weeks' time. Thank you very much.